So we're going to talk about how to solve pH and pOH problems. And then the new concept is the factoring in of what a pH scale means, which means it's a log scale. So the first big idea here is pH plus pOH equals 14. So if I look at my first sample problem in the table, my hydrogen ion concentration is written here in standard notation. If I write this in scientific notation, it's 1 times 10 to the minus 4. Make sure my minus sign you can see there. And the unit on that would be molarity. So again, I moved the decimal 4 places smaller, so it's 1 times 10 to the minus 4. pH then is 4 because it's the negative of the hydrogen ion concentration of that exponent. That log scale, again, remember, it's that power of 10 scale. So using that idea here, the pOH is pH plus pOH is 14, so my pOH would be 10. Then if I look at this, remembering that pH is less than 7 are acidic and greater than 7 are basic or alkaline, I can classify this as acidic. So most of that, other than the pOH, is stuff we've already done. However, we do have a little bit new with this, and the little bit new that we have is this idea that the pH is a log scale, meaning that a pH change of 1 is really a factor of 10 of its acidity or its how basic it is. So pH of 3, if I compare a pH of 3 to a pH of 5, okay, to go from a pH of 3 to pH of 4, I go pH, this is a factor of 10, this is a factor of 10, so it's actually 100 times more. Or if I thought about it this way, it would be here, this is pH of 3, and this is pH of 5, so the difference between this was a factor of 100, moving the decimal 2 more places. So that's the big idea with the how much more acidic. So this question says, how many times more acidic or basic is this than neutrality? So neutrality is neutral, which is a pH of 7. So the difference between 4 and 7 is a pH difference of 3, which would be 1, 2, 3 zeros. So it would be 1,000 times, and it's more acidic. More acidic. Okay, it's 1,000 times more acidic because I'm going to a lower pH. Let's go ahead and try the next one then. For the next one, pH of 9, so my pOH would have to be 5 because 9 plus 5 is 14. My hydrogen ion concentration is 10 to the minus 9 molarity. And I look at this pH. This pH is 9, that's greater than 7. So this is a base, or it's basic. Now, knowing that pH of 7 is neutral, pH of 9 would be 2 places bigger. So 2 places bigger, so it would be 100 times. But now I'm more than 7, so it'd be 100 times more basic than neutrality. Because again, neutrality is 10 to the negative 7, so the difference between 10 to the negative 7 and 10 to the negative 9 is a factor of 100. 100 times this would give me 10 to the minus 7. Next one, I have a pOH here of 9, so that's going to give me a pH, in this case, of 5. So my hydrogen ion concentration would be 1 times 10 to the minus 5 molarity. Since this pH is less than 7, it is acidic. And so between 5 and 7, I'm going to move 2 decimal places. So this would be 100 times more. I'm going more acidic because I'm going down with my pH scale. The last one, pH of 1, so my pOH would be 13. So my hydrogen ion concentration would be 1 times 10 to the minus 1 molarity, or 0.1 molarity, either would be fine. This is a pH less than 7, so it's definitely acidic. And so now to go from 7 to 1, I could look at it a couple ways. 10 to the minus 7, 10 to the minus 1. So to get those two, I would have to multiply this by 10 to the 6th, which would be 10 to the 6th times more acidic, or 1 million, as we know. This would be also 1 million times more acidic. Either way would be fine. So again, big idea here. Sorry, right there, you can see better. Big idea here is that pH is a log scale, so a change in 1 on the pH is really a factor of 10 in terms of its acidity or being basic. Thanks so much. Go ahead and do the next page of problems in the notes and then use the link to check the key to make sure you're understanding. Thanks.